Today, we'll be solving LeetCode 155, min stack. In this problem, we are asked to design a special type of stack. This stack should support all the regular stack operations, like push, pop, and top, but it must also allow us to retrieve the current minimum value in constant time. That means O of 1 for all operations. Normally, with a regular stack, getting the top element is straightforward. But finding the minimum would usually require scanning the entire stack, which takes linear time. Here, the challenge is to keep track of the minimum value efficiently, even as we push and pop values. Let's first think about how we can design this. The key idea is to use two stacks instead of one. The first stack is the main stack, which stores all the values as usual. The second stack, which we'll call the min stack, will store the minimum value at each level of the stack. This way, the top of the min stack always holds the current minimum. Now, let's walk through the code together and break down how it works, line by line. First, we define a class called minStack. Inside the constructor, which is the function named init, we initialize two empty lists. We set self.stack to an empty list. This will be our regular stack. Then we set self.minStack to an empty list, which will keep track of the minimum values. Next, we define the push method. This function takes in a value. So we say def push with parameter val. Inside the method, we call self.stack.append with val. This adds the value to the top of the main stack. Then we handle the minimum tracking. We check if the min stack is empty. If it is, or if val is less than or equal to the last value in the min stack, then we push val onto the min stack too. So we say if not self.minStack or val less than or equal to self.minStack at index -1, then append val to self.minStack. This ensures the top of the min stack is always the minimum. Let's move on to the pop method. We define pop with no arguments. First, we check if the top of the main stack is equal to the top of the min stack. So we say if self.stack at index -1 equals self.minStack at index -1, then we pop the min stack too. This step is important because if we remove the current minimum, we also need to update the minimum stack. After that, we pop the main stack by calling self.stack.pop. Now let's look at the top method. This one is simple. It just returns the last item in the main stack. So we say return self.stack at index -1. Finally, we have the getMin method. This returns the last item in the min stack, which is the current minimum value in the overall stack. So we return self.minStack at index -1. Each method, push, pop, top, and getMin, takes O of 1 time. That means we can use this stack in any scenario where we need to track the current minimum without slowing down performance. And that's how you solve LeetCode 155, min stack. Thank you for watching and let's keep learning.